using the recurrence relation, trying to find a rule to get us straight to Vn. So, our example is a $10,000 investment earns 8% interest. Here's the important thing, compounded quarterly. How much will the oh god, I forgot to type the investment be worth in 2 years? Pretend that's typed. Now, the recurrence relation is not easy, but it's something we've done before. We know that the initial value is going to be 10,000. That's not so bad. Then how to get from one to the next? Well, remember it's compounding quarterly. So our steps from one to the next are quarters of a year, and this goes up 8% per year, meaning each quarter it will go up by 2%. So here we know that quarter means we're going to do the rate divided by 4, which means 2 in our case. So here, each quarter we increase by 2%. So we're looking at Vn plus 1. To get to the next one, we take the previous one and multiply it by 1.02, meaning we are increasing the previous amount by 2% every quarter. Now let's see if we can establish a rule for that. Well, a rule for that would look something like this. If we started with initial 10,000, let's try and see if we can spot a pattern. We're going to take that 10,000 and we're going to multiply it by 1.02, and that will have increased some portion. Then the next quarter on, at the end of the second quarter, we're going to take the value from above. That's that value there. And we're going to multiply it by 1.02. And then same again. We're going to multiply it by a third time of 1.02. Each successive quarter, we increase it by another 2%. And each time we increase it by another 2%, we multiply by 1.02 again. So here, I can see that for the fourth quarter, we'll take the 10,000 rather, and now instead of writing out times 1.02 times 1.02 times 1.02, what's going to happen here is that's going to be multiplied by 1.02 to the power of 4, because it will happen 4 times. And this leads us towards a rule. The rule for Vn is VO, the amount we started with, multiplied by the common ratio, meaning the amount of percentage increase or decrease each time, to the power of n. So for example, here, if we want to find out how much this investment will be worth in 2 years, 2 years is 8 quarters. So V8, we're thinking 8 jumps in, we'll have 10,000 multiplied by, now the common ratio is 1.02 to the power of 10. Why did I say 10? I meant 8. 8 quarters in. Now, some of you who have done financial mathematics last year will say, this looks a lot like the compound interest formula. And yes, that's exactly where the compound interest formula has come from. It's come from recursion, and last year we just jumped straight for the formula to use it. But you might notice that this here is the percentages per quarter. This here, the 8, is the number of quarters we're going with. Is exactly the same as we did in year 11. Alright, so let's actually work that one out. And once we've chucked that in our calculator, we can see this is $11,716.59. Alright, so the rule for this is if we have the recurrence relation, where starting value, and then we get from one to the next by multiplying by a common ratio, the rule for jumping straight to the nth term is r to the n, the ratio to the n, times the initial value. Alright, so how do we use that to model this? John wants to save $7,000 for holidays, so he invests $5,500 in an earnings account that earns 6% compounded annually. Now, how long will it take him to save $7,000? Well, let's think about the rule for this. The rule to get to the value at the nth year, because it's annually, will be equal to the initial value, 7,000. Sorry, 5,500 is the initial value. multiplied by the common ratio. Common ratio is the amount it increases or decreases each year. 1.06 and to the power of n. Here we want to find out how long it will take him. So what we do is we want to find out how long it will be worth until it will be worth 7,000. So we set the value at 7,000, 5,500 times 1.06 to the n, and then solve for n. Just in Solver. You don't have to know how to do that algebraically. Beautiful. Alright, we will do far more practice in class. You can chuck that in your calculator solver yourself. Thank you very much.